In this video, I'm going to explain how to solve the Chinese Postman problem for any graph. I'm going to start by first constructing my own custom graph. Now that the graph has been constructed, it's time to complete the Chinese Postman algorithm. In the Chinese Postman problem, the problem states that a postman starts at any vertex. He must travel along every single edge in the graph in order to deliver mail to all of the houses. If there are any vertices of odd degree, some of the edges have to be traversed twice. How should he design his walk so that he travels the smallest distance possible? The first thing that we're going to do is we're going to count all of the odd vertices and then consider every possible pairing of the odd vertices. So let's start with vertex A. Vertex A has 3 edges that are attached to it, meaning that vertex A has odd degree. So I'm going to make a list of my odd vertices, starting with A. B is even, C has 1, 2, 3, 4, 5. C is odd. D has 2 that's even. E has 1, 2, 3, 4, 5 that's odd. F has 2 that's even. G has 3 that's odd. H has 1, 2, 3, 4 that's even. And then I has 2, which is even. So there are 1, 2, 3, 4 different odd vertices. So there's a result in graph theory that states that the number of odd vertices in a graph is always an even number. So it's always possible to pair up all of the odd vertices. So the next thing we're going to do is we're going to consider every possible pairing of the odd vertices. So for example, for the first combinations, I can consider pairing A with C and E with G. For the next pairing, I can do A with E and C with G. And then next I can do A with G and then C with E. Okay, so that makes up every possible pairing of the odd vertices. The next thing that we're going to do is for each pairing, we're going to calculate the minimum weight for the trail between those two vertices. And then for each pairing of these 4 vertices, we're going to calculate the total weight of that pairing. So first, let's consider the pairing between A and C. So here is vertex A, here is vertex C, and then we're going to calculate the shortest weight of a path that connects A with C. So in this case, the direct edge of weight 4 is the minimal weight between these two vertices. So from A to C, I have a weight of 4. And then between E and G, here is E, here is G. The minimum weight is the direct edge of weight 3. So we get a total weight of 7. Next, let's consider A paired with E. So here is A. Over here is E. We have a couple different options to go from A to E. So it looks like I can go from this edge of weight 4 and then this edge of weight 2 for a total weight of 6. And that is going to be the shortest path between those two vertices. So from A to E, we have a total weight of 6. And then next is C with G. So here is a vertex C. Down here is a vertex G. It looks like the shortest path between those two vertices is going to be this edge of weight 2, this edge of weight 3, for a total weight of 5. 6 plus 5 gives us a total weight of 11. Finally, on to our last pairing, we then have A paired with vertex G. And it looks like there are going to be 3 edges that make up the shortest path between those two vertices. So it's 1 plus 2 plus 1 for a weight of 4. And then between C and E, the shortest path is this direct edge of weight 2. That gives us a total weight of 6. Therefore, the pairing that has the minimum possible total weight is A paired with G and C paired with E. That means that the shortest route between A and G, as well as the shortest route between C and E, has to be traveled twice. I'm now going to compute my algorithm for the Chinese Postman Problem. Let's say that I start here at vertex A. This is my starting vertex. Okay, remember that I have to travel between A to G twice and C to E twice. Let's start with the shortest connected edge here of weight 1. That gets me to vertex I. From I can travel to H. From H, I can travel to G. And now I'm trying to think of how I can cross the shortest path between A and G and C and E twice. So here I'm at vertex C. Here is vertex E. So maybe we'll go here one time. Then I need to do A to G. So I'll go down here. I'll travel back to vertex A. And now I've arrived at vertex E. I have to get back to vertex A. And now, let's see where I'm at. E to G. E to C. E to C. Okay, that one's crossed twice. And now go back to vertex A. And it looks like we have solved the Chinese Postman Problem. So the minimum total weight for the Chinese Postman Problem is a weight of 40. So if we look at our pairing of the odd vertices, the shortest path between A and G should be walked twice, and the shortest path between C and E should be walked twice. So here we can see in blue, this represents the shortest path between vertex A and vertex G. Since these edges are in blue, that means that those edges have been traversed twice. And then last we had the shortest path between C and E. That is this direct edge of weight 2. That is in blue, meaning that that edge has been traversed twice. So we have solved the Chinese Postman Problem, and we have found that the shortest route for the Chinese Postman Problem has a total weight of 40.